Cool. So yeah, learn Noir in the afternoon, but it's not really afternoon, but the mornings.
And yeah, food.
Yeah. So you're actually not learning in an afternoon. Okay. Gonna learn Noir in 1 minute.
Did I get our money back then?
I mean, it didn't pay to be here. So yeah, learn Noir in 1 minute. It's just like the proposition here. So basically, it's just, like if you're in a hackathon, you're like, hey, you know Rust, and yeah, you also need to say that you start. You can do it. Try that to do the right Rust. Cool. Thank you. See you tomorrow. Okay, but if you don't know Rust, then you're like, what now? Great. I didn't know Rust, so I had to learn more. I didn't have to. But basically, this is it. Like, it's mostly a mental model. Like, it's not necessarily a language. It's not that hard. Like, languages are easy. You just ask ChatGPT to write Rust, and beautiful, you have Noir, a Noir program. It's more about like what you're trying to do. Yeah. So can they be exactly the same? Not really. There are some small things, but again, the front end is not the problem. The problem is the mental model. So let's go with the agenda. Like, first I'm going to rant for 1 hour about how ZKVMs are on ZK. Okay, no, that's going to do that. And then just talking about ZK for ZKs, and then why do we talk about Noir so much if our business is on Aztec? Like, if we're trying to deliver blockchain, why the fuck? So why do we why do we talk about Noir so much? And then yeah, just as at the end, like last 10 minutes, we're gonna solve the global peace.
But that's the afternoon one, right?
Yeah, enough.
So this sort of encountered in the hour, you get a full hour for the rest, and then an extra 10 minutes of global peace.
Yeah, that's basically. So ZK for ZKs. If you're like me, you don't know anything. So basically, yeah, let's just go through some of the, like, I'm gonna explain ZK for you. Right? It's very simple. If you don't know ZK, just not gonna be a problem. Just start with the basics. Like, you get this equation, no problem, right? You can, I think people can see what this is, like, no problem. So if you're following, you're like, oh yeah, definitely, I'm definitely following this. Then you can very easily observe that this is also true. And that's the problem. Like, you get most of the ZK. The papers are like that. Oh, you cannot. You start reading it like, oh, I can get this, and then suddenly it's like pinch the mouth, and that's when you give up. So I'm doing this to you, so you feel how it was for us for the last 8 years to understand ZK, because you could actually write the circuits like bare bones. They are basically circuits. Like, you can do like circum stuff, like when you can connect wires and everything. This is what we did after some time. It's like, but then you get like this kind of like, you actually don't know where you are. It's just so much stuff when you deal with things at the bit level. And so that's why we came up with Noir. So Noir is meant to just abstract all the. So yeah, you know how researchers are like, they always want to show that they like the math. We are totally not like that. We hide the math. Like, that's the point of Noir. Just hide everything, just expose an easy language. Yeah.
So, like, programming in general, like, is pretty quick to pick up where bottlenecks and so forth are. But when there's a load of mathematical abstraction underneath, so things that are simple in normal, binary arithmetic, and which look simple and then simple in your code, might actually be really complex under the hood. So any way to like see like whether what you're doing is like hugely wasteful, for example.
Yes, there is a way. Like, when you compile into an R circuit, you get the ECR, which has all the opcodes, and you could actually see which one of them will do in the backend, and you can actually optimize them very well with that. So there's definitely, I'm going to talk a bit about that in a second. Well, how just being easy doesn't mean it's gonna always be efficient. If you ask a Noir core team developer, I've had once a discussion with one of them, and he was like, "No, it always has to be the most efficient, even if you write shitty code." And I was like, "That's a nice way to see it. That's not true. Like, if you write shitty code, like it's just like any other programming language. You can't expect the compiler to always have your back and make it as efficient as possible. If you write shitty code, you're gonna have shitty execution, and same with Noir. So yeah, there's definitely a way where you can go into the depths of it and try to optimize it on the back end. Yeah.
So yeah.
Like, if you see the big number libraries, for example, that's like quote, you can barely understand what's up there. Like it is Noir, but the guy just really goes at the most optimized way of doing things because he knows how the math works behind it. So that's why he wrote a very, very efficient Noir big num library. Yeah. So yeah, why Noir? So Noir, ZK is cool. Not Telescope. Telescope is cool as well. ZK is cool. You can well, we were here because we like CJ. We are interested in knowing how can you prove big competitions using a small proof, or how to prove big competition in a small proof and retain some of the privacy and not reveal some inputs. But it's also hard. Like yeah, we get this circuits thing. We're trying to kind of reframe circuits into programs. I get the idea of circuits nice, but in the end, because you could actually think of them as like logic circuits, and quantum computing also uses circuits. So we can, yeah, we did something better. Kev, which is the original gangster for now, is like, yeah, Rust is cool. Even though he's a Python guy, he's like, I like Rust, so he just copies it. Then, not after 3 years, almost like 3 years, I would say. Yeah, it's really cool. Now we're, yeah, it's almost like magic, and I'll show you. So Noir is the de facto ZK DSL, domain-specific language now. It's not like I couldn't say this a year ago, for sure. It wasn't. Now it is. So just being honest, you like no one in the right mind will do any ZK for privacy using other language, because there's only like two or three more. There's definitely like the RISC-V, everything, but those are not zero knowledge. They're not privacy. They're just execution, which is cool, but it's not really the same thing as Noir does. So you want something that is fast. You want something that is powerful, and has actually this look like now. And we kind of go to the usability of the thing. That is cool. Just some examples of how easy it is. Like just a simple guessing game. I'm thinking of the number. I will prove it that you didn't guess by number. There's simple example. You define the inputs. You define which ones are public, because privacy is normal. So you only care about the public inputs. You say which ones are public. And then you use this assert, which is probably one of the small differences between Noir and Rust, because Rust doesn't have this keyword assert. Assert will just do that. Just the circuit will assert that X is different from Y. So the verifier will only know Y. They will never know X. They will need Y to verify the circuit, but they won't need, or they can't use X. They can know yes. If they text. A pre-image knowledge proof. This is proving that you know a password without revealing which password it is. So actually, you would use Poseidon hash. This is not Poseidon hash. Poseidon is more optimized recently. But yeah, I'm thinking of a password. I can disclose what's the hash of the password, right? Like it's a hash. Everyone can know it's the problem. So you can put your hash on chain. And basically what you have is in the zero knowledge program, you are proving that if I was to hash my password, it would be the same as the hashes, the non-hash. But I do that without revealing what the password is. So it's kind of black magic thing, right? That's the magic. That's the alien thing of Noir. You can prove something without actually. You can prove that hashing password will go to will first represent a public, hash without revealing the actual payment. Then it's a semaphore, which is a primitive. It's called primitive. It's like proving that you are a member of the real human group. I'm saying real human because that's exactly what World ID does. They have a number of humans in a semaphore. A semaphore is a Merkle tree, and basically you can prove that you are one of the leaves of the Merkle tree without revealing who you are. So if you don't know what a Merkle tree is, just a tree. Like you have one. You have a bunch of leaves would be the identities, and basically you hash two of the leaves, and then it hash two of the hashes, and so on until you get to a root. And basically what you can do with Noir is proving that you are in this tree without revealing who you are. Just prove that you are there. That's the principle of semaphore. It's a primitive. It's a PSE team is building. Semaphore contributors to that project. But is it fast? Like that's I always get triggered by that because I don't even know and I don't care. Like if it's fast, most of the times it is faster than most alternatives, but I don't care. I'm going to tell you why. First, as it depends on the backend. So if you use a Groth16 backend, there is no reason why it wouldn't be faster. Like Groth16 is faster than Noir. So if that makes the difference for you, then go ahead. Like again, World ID, they use Groth16 because they want something that's fast and it's cheap to verify on chain, so they can use it. They still use Noir, they just use a different package. Yeah. So that they come with the different trade-offs. For example, Noir is universal. You don't have to have if you use a Planck. Turn this off. If you don't have to use if you use a Planckish like Bratenberg backend, you only have one trusted setup for all the circuits that you may want. With World ID, they use Groth16, so they actually have to have one trusted setup for that specific circuit. If they change the circuit, they have to do another trusted setup, which is a pain. But that's fine for them.
Can you zoom out a little bit on how you'd plug in different packets as improvements?
I'll show you in a second.
Like what levels do it?
Yeah, I'll show you. This is what I meant. Like your program, the way you code it definitely depends. Like if you code it, if you know what's going on in the backend, then you can improve it. So that depends on the speed as well. And then finally, is like, do you care? Do you really care? Because yes, you can. For example, for semaphore, if you have different trees for different depths, like different number of members in your tree, it leaves in your tree, you actually don't know that, and when you know it, then you're gonna download a specific verification key for that specific circuit. And that it could be from 14 to 80, 300 megs. On your phone, you're waiting, you're not even doing anything, you're just waiting for it to download 300 megs. Is that good enough? Probably not. So, for example, with ZK Passport, they use Noir because they use Bratenberg, they use Noir because there is a ton of different passwords in the world, different codes, different hashes, different signature types. So you would actually scan your passport and then wait until it downloads that specific verification key, depending on what passport you have. Kind of a pain, right? Maybe you don't care about it being fast, you care about it being usable. So yeah, actually nobody cares. Like it's most of us don't care. Okay, I'm not saying that Groth16 you shouldn't use it. You should definitely use Groth16 if you care about speed. If speed is big deal for you, but you get all the trade-off. Wow.
Well, actually, maybe
So the easiest way of using Grok 16 is probably not even using Noir. It's maybe Circom is probably the best choice. But again, you can use your Grok 16 backend in Noir, no problem. You can sit here and show them. That's because it's the one. It is wrong. Sure.
shoot.
So it's only usable as a DSL. Yeah, this idea of like abstracting complex circuits into code is not even new. You have punch cards and people. You could actually go and code in machine code. Nobody does that. Like everyone abstracts that away into a language that actually compiles a different machine code depending on the CPU you have. So it's not even new. Everyone has been doing this for forever, right? Talking about Grok 16, yeah, definitely. If you want to, it could be usable for you, but most of the times you'll like a backend that works for everything. So, the gas thing, which is like some people are like, you should use ultra honk, like which is the latest iteration of the Berettenberg prover. If you use ultra honk, it will take 1.2 million or 1.5 million gas to verify. Yeah, sure. Definitely with Grok 16, you can get 300K, but are you paying for 300K gas on layer 1? Probably not. Like, nobody does that anyway.
We're going to.
And then it's the mobile usability. This is a big deal. Like, most of the traffic is on mobile. So you want something like ZK password to scan, and then you do the proof on your device. Aztec transactions will be done on mobile phones, because otherwise, if your private input needs to go to a server somewhere, it's not private anymore. So computation needs to be done on your device. You want something that is mobile friendly. It can be used on mobiles. Cool. Achieving global peace in afternoon. Yeah, I'm gonna skip that for another day. Just kidding. But it could be done. So generally it's gonna be very easy. Just gonna see some Noir tooling, install some Noir tooling, then writing some Noir code, and then proving it and showing it like on maybe Remix or DE, something like that. Cool. So the Noir Discord, if I join the Discord, this is the documentation website. Online, we don't have a website, we only have docs. For now. And this is the workshop resources. You can scan this QR code or just visit linktree/Tinkerful. And we're going to find on the resources, Linktree. This is where we're going to land. Here you have two things. One is the code space. So if you don't want to install anything locally, you can actually use code space, and this will lead you to a code space, which is like a VS Code session that runs on the cloud that already has Noir up and BP up. So you can skip the first part of the workshop because that's already installed. If you want to install stuff locally, you can use this cheat sheet, which will click here. I'm gonna tell you, I'll give you code space if you want, and then manually you have these two commands you could copy. And I'm gonna run them with you. So yeah, just feel free. Any questions so far?
So we turn up.
Cool.
With this code, use your range. There's not very fine.
Explanation board.
You can super process.
Just
me, bro.
What are we installing with Naga?
Sorry?
What are we installing with Naga, probably?
With Nago is, cargo for Rust. Nago is like the package manager and the runner for Noir.
So then,
running the first command will install you Noir. Okay? So Noir, it's just like you have Rust up, which installs Rust, or in this case, it will install cargo. Noir will install Nargo. Okay? So after running Noir, you have, after downloading Noir, you just run Noir. And the cool thing is that you can easily change between versions with Noir. You can put /v and then put the version that you want. You can leave it just nothing and install the latest Nargo. Okay, latest stable version, which should be Noir version 1.0.0 /beta.6. So yeah, we're getting like OpenAI level naming, like poultry, poultry plus pi. Really,
Yeah.
guess things are a bit slow here. So yeah, Nargo will let you run tests, run compile, execute, generate witness, stuff like this. After installing Nargo, you can go on Nargo.version, and it should tell you what's the latest version that you have installed, which, as I said, would be 1.0.0 /beta.6.
And I think
After this, you need a backend, because as I said, Noir is just a front-end language. It will compile, it will test, it will do some things, but it won't actually prove. And you want to prove. But so to prove, you need the backend. So for this case, we'll obviously install Berlatenberg, which is, I guess, the only usable prover except for the MoreID one that I actually never tried it. And also the one that powers Aztec. So Berlatenberg is the core of the brains of Aztec. Everything is done, client-side is done with Berlatenberg. So for that, you install the second command. So be here, copy it, and this will install bb-up. So same thing as NoirUp. NoirUp installs Nargo, bb-up installs bb. bb stands for Berlatenberg. So after installing, just the same as you did with NoirUp, you run bb-up. bb-up will get the latest Nargo version that you have and install the correct package for that. So it will match already, because they can sometimes mismatch, but bb-up will take care of that. So it will say, yes, the version for this version of Noir, the best version is Berlatenberg version 84. So it will install version 84.
Sorry, could you show the repo again? It's not an link tree.
It's on version? It's like cheat sheets.
It's there. Is that the GitHub?
Yeah, it's here. And you want to go to the cheat sheet.
Okay.
There's instructions in the one.
Okay. As it just this one.
Yeah, and there's like installing manually. You can use the code space, and if you use code space, you should already have NoirUp and bb-up. You could just run them. So yeah, DB, it's still downloading, 16%. So okay, also just running, and we can keep going because we only need bb-up now in our role. Cool. So there's the commands that we're going to be using as well. So if you get lost at some point, you can always use this. Just like
Can you walk us through the next block? Because I did that and it just
you mean this?
it doesn't create
value class for X.
Yeah.
Valid. Is it something we're going to code and change? Is it?
Sorry.
So when I did Nargo execute, the value passed for X is invalid.
you need to fill in the values.
Yeah, it's meant to be, mostly if you lose part of the workshop, you can always use those commands. Just also for me, because sometimes I forget. So cool. So Nargo. Get Nargo version. If you just run Nargo, it will tell you which command do we have. And so the ones that I actually care now, it's Nargo new. I'm gonna Nargo new. That's the name of the workshop, and the name of the folder that it will create will be workshop. So here we have, it's just some examples I have to show you afterwards. So this is the default project, and the default project is actually, I know you can see it, yeah, but it's very close to the screen. The default project is actually this guessing game I was telling you about, right? Have an X, have an I, Y. Y is going to be public, so everyone can know. X is private. Yeah, you're asking like, oh, what if I can just change X when I prove that you didn't guess my number? Of course, This is just an example, which is not meant to be production ready. So I'm gonna CD into that folder. And let's run these Nargo tests so I can show you how cool it is. So Nargo test, actually, if you install the Nargo extension, I think it will come to you and say you already installed the Nargo extension. Otherwise, you can go into the extensions and just search for Noir. But if you have it, then it will basically, like you have this little thing that you can run just as test or different tests if you want. So you can have your own actual test suite. You can actually have a test suite that is meant to fail. So it's just create a test that is meant to fail. It's just like test to fail. And actually I can like copy this whole thing and just make it supposed to fail. Test fails. I can go like what happens if what happens if 1 is equal to 1, it should fail, right? Like my circuit is proving that X is different from Y, so if my inputs are the same, then it should fail. So I can actually run test, lots of tests fail.
Can you make it fail argument in the test fail, like? Because it is not working for them.
I mean,
Just make it fail. You should pause.
oh, it should fail. Yeah, test 1, so test fail.
That you can start something wrong, like because that's passing for me. I have focus.
That's weird.
Check bugger.
But yeah,
Okay, whatever. I mean, I feel into the bug every single one of us ends.
should take it.
Man.
So yeah,
It,
but these are just tests. This is easy if you want to test something real quick without having to change. If you have go into the back end, this will be much faster than actually proving every single thing. If you want to actually have something that is able to be proven, you want 2 things. First one is you want the intermediate representation, because this is just code, and just as you can just put C++ code into a machine, it won't know what it is, you need to compile it. But here it's just the same thing. You need to compile it into a representation that the backend can understand.
so wow.
So you do that by running NoirCon2. Okay? NoirCon2 will create a target folder in this case, and we'll show you this nice JSON. Trying to get it to pretty far anyway, which just tells the backend which Noir version it is, because it plays to, and then there's just an API and say, oh, the bytecode represents this and this and this and this. Just like in Ethereum, you have like a ton of bytecode, and then you have an API to tell the interpreter how big is each of the fields under it. So and then you have the bytecode, which is the base 64 encoded stuff, which is basically your circuits. So you could have some fun decoding this if you want to.
It's in the Control-Shift-P menu, by the way, format document
Sorry?
to format the JSON.
Yeah, I think it should go like JSON format.
Format document, by the school.
Yeah,
Command Shift I should be.
yes, format document. There are multiple. Okay, yeah, no problem. You guys, you don't actually have to look at these. I'm just showing you how does the thing work behind the scenes. What you want now is to prove. So I'd say that in order to send this to the backend, you want 2 things. The first is the compiled circuits. So again, the backend can understand it. And the second one is the witness. Witness is something that you always need in any ZK language. Like witness is absolutely necessary. Witness is the solution of your circuit. You basically it's saying, yeah, I know what are the inputs that will make this thing solve. It's like you can think of an equation, right? It's the witness will be like the paths that you need to go in order to get to the end of the equation.
Yeah.
So to generate the witness, first we're gonna go with an argo check, so it creates a new and nice prover.toml.
So like the witness is required to generate a proof.
Yeah. In every ZK project, you need the witness. It's just a solution of the program.
Mm-hmm.
So in this case, our program, by running argo check, it will create this prover.toml file. And this is where you're gonna put the inputs that you'll be using to prove. So the verifier doesn't know this. Okay, this is just on your machine. Okay, you can later even remove all of this. Just show you. So to prove, my inputs to my circuit for my proof are gonna be 1 and 2 because they need to be different. Otherwise, it won't happen. So now what I want is to go and Nargo execute. So Nargo execute will execute the circuit and generate the witness. And that's it. Like the witness is here. It's unreadable because it's compressed. But yeah, here's the witness. This is what you're gonna feed into the background. So 2 things: the circuit and the witness. They serve different purposes. The circuit is just for the backend to understand what it needs to prove, and the witness is for the prover to say, I know the solution, I'm just gonna prove it.
And this file name that's like hardwired in Nargo, is it? The file name prover, that's just how we call it for Nargo.
Yeah. You can use the JS. So there's a workshop later on, I think at the end of the day, with Salil, and he's going to show you how to use this in JS in the browser, which is more interesting. But yeah, just showing you basically the basics of Noir, and then in the front end or back end, whatever, on the browser, just it's the same thing, same concept. So you're going to have some knowledge on that. So at this point, I hope BB has installed. Okay, well, I have it installed. Do you have BB? Try. Goes. So you should have BB version machine. So you ready? Now, I will tell you what the version is. In this case, that's fine. That's number 1, version 84. Good, 23. Cool. So we're ready to use the backend in this case. So this is where you'd say, now it's just not it's okay.
So if you like,
This is where Noir is.
do I have the choice of everything that just plug it the same different way? So I don't see where BB is specified.
Sorry.
I don't see where BB is specified as a prover.
It's a different binary. So you just install it and it's completely different. So let's say you want to use a world, let's say that the world ID prover is called world, for example. So since also it would be like a binary, it's completely different thing.
But in this file structure, which is like the one project for this workshop, I see where I have chosen BB.
I'm not choosing to show you. But it will take you.
Yeah, but like if I install 2, how do I know which one to use, for example?
You just use the binary that you want. And if there are 2 different backends, at this point you can choose which one you want to use.
Yeah, what we're saying is in which file or whatever would I choose which one I'm using? Where is that command entered?
I see it. And that's how we have to prove it.
So I don't get it.
You can do it. We have different
So
backends.
this is the answer.
I think like this compiles to
Check.
an ACIR.
Yeah.
So it's like an intermediate representation.
Yeah.
And then the backends know how to read that. So that's how you choose.
Still okay, but how does NoirCon you know which candidates to apply?
And then later it was told to give you the proof.
Which I just overexist that.
So I know.
So we and whatever it was only within the mechanic. So like just I know what the tests are passing.
You win this stage. Okay, the picture.
Something like that for being used at all.
Targeted choose. Oh, yeah, it's a fair.
So that's good. So like if you used to do LS, you don't find to download it. No. Maybe it's a
Restrictive stage. We are raised out once in a week.
This is the weirdest thing. So I don't see the thought about download. It says that it's
Listen, just for the to check and see and get your and then go back where it was tomorrow. Let's check it. When you were right, and I will check right, but if again where this is Jason, what I can see.
Are you at this data folder within already and Noir folder? Do you have any Noir projects? No. In the parent folder of that.
To retell.
No, if the bus then.
Sometimes it's confusing.
Like the path of the exhibits. Yeah, exactly. See which what would it for what not the rest. So it's an argument which is inputs and the
Can you go now go version?
or is there a same materials version? Create a witness. Oh, yes. And now we can
Is it in a code space? Or no? Nope.
talk.
Can you try code space? Just
Yeah, sure.
so you can follow along because I'm really close to first time I see something like that.
Just run the init command.
So is that
It is the because usually now I have to do
Yeah,
the user money with
Cool.
the
Can we-
have space.
yeah.
Oh.
Now,
yeah. Can we go? Can we continue? Yeah.
I've
Cool.
got one actually.
So now we have the witness. We need the proof, right? This is where we enter with the backend. Is that clear about the backend? About
Yeah, so because you're running a particular binary to prove,
yes.
which we haven't done yet. That's
Yeah,
what.
we haven't done it yet.
But-
So we install it. It's BB. The BB binary is the backend. So we choose to use that one.
It is none.
So cool. In order to do that, we just go with BB. So BB is pretty easy actually. You go BB approve and actually have it to both thing here than it was. So can I go over each one of them so it's easy to understand what I'm doing here. So BB, it's done binary, so you can actually go BB help or BB help and see everything that you can do with BB. In this case, what I want is to close. So Berenberg proof this circuit. So I'm pointing to the binary. That's why it's /b from binary bytecode. That's not binary bytecode. I'm pointing to that bytecode which is within target /self. Not self-drop, and self-drop, and probably use actually self-drop. Workshop. And then target workshop. Okay. This is the witness. As I said, the backend needs to know both what it's proving and what is the solution into what it's proving. Then I'm pointing to /o, which just says what I want the proof to be, which is going to be /targets. I want the same folder as this one, target. And then I want, for this particular case, because we're going to be doing this in Solidity, I want output to be format bytes and fields. And there's different output formats. Bytes and fields is just like it creates for the proof, it will generate another file with just the public output, public input, which is cool for digital verification. Because by default, Berenberg actually appends the public inputs to the proof, which can be a little confusing, but no problem, right? And then I'm gonna pass the Oracle hash, which is gonna be check. You're like, what is this Oracle hash? It's just the way that you generate the what was it? I think the last hash. And in this case, you want it to be Kachak because I'm going to verify this on Ethereum. And Ethereum is more optimized for Kachak hashes than if you just don't pass the Oracle hash, it will use Poseidon, which is nice for ZK, for like verifying within another circuit, for example, but not really very interesting for Solidity verification.
And so the Oracle hash is a hash of the code that the router is running.
I don't know exactly what is the Oracle hash, I'm gonna be honest. But yeah. So you want Kachak because it's the most efficient for a student. In this case, again, really depends on what you're trying to do. So now I'm gonna go with
This is just because the smart contract is like an AVM smart contract that will verify.
Yeah.
Happen
in this case.
systems. But it's also not a strict requirement, like Aztec could also.
Oh no, Aztec will not use the Kachak for sure.
Yeah.
Because Kachak is the worst thing possible for zero-knowledge circuits. It's just bad because it's use a ton of multiplications which are quite expensive in zero-knowledge circuits. So you want to avoid that. So yeah, Aztec will not use Kachak. It will avoid Kachak like the devil.
Was Aztec exclusive to Ethereum, or were it also?
Aztec is just its own chain, so we could choose to use whatever primitives are most efficient.
Yeah.
So we use like Schnorr signatures over EM254, and we use like 7 hashes. So we try. It's like it's our own execution. Like you can use the best for our devices.
Okay.
In this case, the best for your device is to use something that's sticky friendly. So we just try to use this. Yeah, there will be Kachak caches on Aztec. You can use Kachak caches in Noir. It's too expensive to make processing. Yeah.
Okay.
So this is where everyone goes crazy about like how fast it is. Like in this case, it's a very simple circuit. So of course it's fast. But if you have a big circuit, this could take a while.
I have a question. I actually get an error. Like I said, I get the import is not large enough.
Maybe you're not putting the correct. So you need to point to the correct JSON and witness. I'm pretty sure that that is a problem. It says like it's not large enough. It's not a great error message. Yeah, when you target to and
Okay, space to it. And
yeah. So now you should have a proof. You have, because we chose to have proof as bytes and fields. You actually have you have proof as bytes, then proof as fields, and then public inputs as bytes and public.
okay, this was a missing step. Yeah, except if the file was there.
So okay, I have to
That's just things. You check this.
So now we have a proof. Let's imagine that I'm Pedro. That's my name. I was thinking of the number 1, and Alice is thinking of number 2, and I want to prove that when she says your number is 2, I'll send you a fact, basically. So
What?
I want to say that you failed. I want to tell her like that she failed, that my number is actually 1, the number I was thinking of. So let's imagine that I am no Alice. That's just Chinese. That's like I can put my collection. I can put my code on. Nice. I'm now another person. So if I'm another person, I actually only have the truth, right? So I'm gonna delete everything else. I'm gonna delete. If I am Alice, I try to guess that the number is 2, and Pedro, this guy, told me I failed. I want to verify that what he's claiming is true. So I'm deleting proof.toml. I wouldn't have this, right? I wouldn't have any of this. I wouldn't have the witness.
So you said Pedro knows you failed, but
Yes. So if I'm Alice, I try to guess the number. I said, your number is 2.
so Pedro says to Alice you failed.
Yes.
Okay.
Pedro says, yeah, you failed. My number was actually not 2. And here's the proof.
Okay.
So what Alice has is just the proof and both people. So actually, Alice also doesn't have the compiled circuit. The only thing that Alice has is this. It's the circuit itself, right? You can actually serve the compiled circuit. There's no problem. There's no tick information. Most programs, especially on the web, they will serve the compiled circuit.
Quickly, the proof here would just show, like, I'm not really into ZK, so I'm asking, the proof would just show that the inputs 1 and 2 from the prover tunnel, that they're not equal.
Yes,
That's all.
without revealing one.
But like what numbers?
Yes.
No.
Only revealing the public inputs, which is fine. In this case, would be 2. But the number Pedro was thinking is not linked. It's private.
But so the Y is then public, yeah?
The Y is public, and we've chosen it to be public.
Okay.
Yes. So as Alice, I don't know anything. I'm no Alice. I'm gonna open a new terminal, and I'm gonna compile this. I know the circuit. Circuit needs to be the same, so I'm gonna compile it. I will compile it. So all good. I have the thing here. I don't need the witness to verify this. Right? What I want to do is now prove that verify this proof, right? Verify that my guess was fast, or verify that Pedro has claimed that my guess was wrong. So I need the verification key, and you can derive the verification key just from the circuit, the compiled circuit. So I'm gonna write VK, which is here I have it filled down, and I say I'm gonna write the verification key for this circuit. So only thing I need for this is the compiled circuit. So I just compile it. I have this workshop.json, which doesn't reveal anything about the private inputs. So as Alice, I've never seen the number X. I will never see it. So I'm pointing to this JSON. I'm also specifying the real hash because I need to do it. And then pointing where I want the verification key to be written. The verification key is very important because otherwise I can just blindly verify Pedro's proof because I need to know what I'm verifying. So it's necessary. That's why it's a key. And you don't need the public inputs, or you don't need anything to verify to generate the verification key. It's unique to each circuit. If I change the circuit, if I change anything here, the verification key would be different.
Okay, but is it unique on each run?
It's
Each time I do write with SSH.
yes, it's the same. And I think of it as a sort of kind of almost like a signature of the circuit. So I know exactly that the proof I'm verifying is from this circuit, right? This is necessary, right?
So if two circuits have the same VK, then they're equivalent.
But yes, they have the same VK, they are the same.
You have to use the same compiler version.
You have to say use the same.
And we've been like Noir compiler has been changing very clean, so
Yeah.
yeah, same version,
But I
same keys.
that's the reason why the JSON comes with an R version. So you are sure to use the same. At least you can be sure. I don't know if it fails. Maybe it fails if you use a different PB that I don't know. Oh no, it doesn't.
So you're saying two equivalent circuits could have a different key, but not
They could, yeah. They could have, depending on the PB or the Brereton version is.
By equivalent circuits, I mean they're just doing the same checks, like kind of the,
equivalent.
the program that it looks
Sensible sense.
Yeah. So yeah, there's this subintended idea that you have the same compiler version. So now I'm gonna go PB verify. I need to specify this key. I don't need to specify this key, so I need to. It's by default it's gonna be ultra. And I'm gonna verify the proofs. So I'm gonna verify target. I don't think this will pass. It probably will. Should need the proof. Stupid /p. That's fine. It just assumes that proof is in this folder, but I'm gonna target proof. And that's it. Like proof is verified. And that's basically it. Now you're like, what if I want to put this in a Solidity contract? So there is no interaction between Alice and Pedro, and I can just put, and I have a circuit that says, just verify this proof on. Pedro can actually send this to a smart contract. Doesn't need Alice to verify the circuit. So you can do that by generating BB, right? Solidity verifier. I'm just specify all contract, but you can actually also specify the verification key, and you can also specify the witness. It just assumes that everything is in the target folder. But I can go verification key and say target VK, and then I can go to find the bytecode and say also target workshop. Yeah, I'll say JSON, no problem.
Yeah, right.
Oh, the workshop was not displayed. Yeah, then I need to. So yeah, now I have a Solidity control. I can deploy this. Okay, so I can go on Remix IDE. So I'm moving a bit faster because I'm getting kicked out. So when you start, is it supposed
12:15.
Oh, okay. So we're ready. Sorry. Yeah, but basically,
I got a little time after because it's lunch after mine, so
Okay.
I'm like super stacked up. But
no, a bit faster.
yeah.
Just a minute.
So I'm just gonna create an empty project.
10 minutes get quicker for this.
Gonna create the whatever. So it's all gonna take this Solidity contract, gonna copy it. You would use this in hard hat usually, right? I'm gonna compile this. Just gonna put some optimization here, so it's so it doesn't find too much. Then I'm gonna deploy this. Which one? All of these are libraries. I just know that the only one that is not this Humper flag. and deploy these contracts. And you see, it asks me for the proof and the public inputs. So as you can see, no privacy leak here.
What is early?
I'm gonna take the proof. Proof is here. It's kind of hard to read, so I'm gonna. There's a
Short fields, there's the proof fields.
yeah, but those are fields. It's a different encoding. So in the cheat sheet, there's actually a nice way to get the proof
Like 3 years.
here. This will give me the proof in XML format, which is what the Soji content expects. This step could actually be nicer than it is, but
I think we can just buy pistol 3B copy.
yeah, I'm just copying manually like old school copy.
Yes.
So in Remix, I go just put the proof here. I think it's a 0.8 at the beginning, and then public inputs. I have it here. See, so nice cells. Just gonna copy it. That's why I use this proof of it in the Bison fields. So is it like I should call it and this should work? Yeah, it did. Nice. So I can see here like this thing actually verified. You see that I wasted 1.5 million gas. We can get this down at some point. But yeah, basically what I'm doing here is like I'm proving to a smart contract that so Alice, so I am proving that someone else failed to encast final.
Does the gas cost scale badly if you do something more complex, or the baseline is high?
Its baseline is about this. If you add public inputs, then it gets slightly more expensive. So it really depends on the economy, because it's just the call data that you need to pass into the contract. But it is going to be about this. We're going to optimize this at some point, like to be less than 1 million gas at least.
That's very cool.
Yeah.
So mostly scales with call data.
Yeah, we don't care too much about the cost of the gas cost at this point, because we care mostly about Aztec, and Aztec will be very expensive. There's only one proof that will go into Ethereum. So, and that proof will contain thousands of transactions. So it's like not really something that we care so much about right now. But yes, maybe later we're gonna optimize this for the boss.
That's been.
Because
If I was
Ethereum usage, which is not the main usage for now.
if I was caring about gas, if you said also the university or whatever, it's mostly the cost of the call data rather than the actual circuit size.
Call it it's really tiny. It's mostly about the execution.
It isn't the wide scale execution.
So you either use another L2 or another backend. So if it's a big deal, I'll go to one or the other.
Just
Because the Starknet is very cheap. The verification on Slacknet using Garaga. So yeah, you can go into the documentation. There's documentation of Garaga. I'm using Rotenberg for Garaga for Starknet. Very cheap. So that's a good solution. I should maybe start using these examples in doing stuff. And
This is right. No.
oh,
thanks.
thank you.